Edge designations, CFA Level 1, pre-reading, economics, learning module 1, topics in demand and supply analysis. All in all, in the pre-readings related to economics, we've got 7 learning modules. This is the first one of 7 where we do topics in demand and supply analysis. As per usual, what we do, those that are familiar with our Edge lectures and notes and videos, is we produce the learning outcome statements for learning module 1 and for all the learning modules on the very first page of our notes. In addition, it's also become a requirement of the CFA Institute that all prep providers do in fact show their learning outcome statements. There we go. And learning module 1, just before we get going, by way of a small introduction, okay, that is your stock standard, nothing too crazy, demand and supply analysis. You can be rest assured we'll be dealing with things like elasticity of demand, supply, income, prices, substitutes, normal goods, inferior goods, marginal returns, all the good stuff that we are used to when we do economics, generally at a university type level, will be shown us. We will see those here again in learning module number 1, topics in demand and supply analysis. Nothing too crazy, shouldn't upset anybody too much, this particular learning module. Okay, and as per usual, what we do is when we are handling a specific learning outcome statement, we reproduce that one then again for you. Let us have a look. Okay. Learning module 1, topics in demand and supply analysis. Calculate and interpret price, income, cross-price elasticities of demand, and then go and describe factors that affect each of those measures. And we start off from the very beginning, a little bit of economics. Okay, what is economics? Okay, because remember, this is the very first learning module related to economics, so we've got to start with that. It's the study of production, distribution, and consumption. Okay, and we generally break economics down into very broad concepts. Okay, macro and microeconomics. Some people might say, what about international or global economics? Yes, of course, but these are just 2 very general categories. Okay, macroeconomics generally deals with aggregate economic quantities, national output, national income. We'll see later on we deal with things like GDP, GNP, all those kind of good concepts. And microeconomics focuses on to consumers and firms. Okay, demand analysis. Let's start off then with the consumer. Okay, and we talk about the fundamental model of the private enterprise economy is generally that of supply and demand. And as we go through this particular learning module, see everything as supply and demand, and we just see the interactions between the two. Yes, be very ready to expect many graphs, many diagrams, as is the way generally of economics. Okay, we're looking on the first side of the model because it's demand and supply. We're looking on the very first side of the model, the demand side. We're going to focus on elasticity. We'll talk a bit more about that. Substitution and income, and normal and inferior goods, and how all of those interact on the demand side, specifically initially here for the consumer. Okay, we look over here, demand concepts. Okay, and we start off with the law of demand, nice and easy. And the law of demand, it's an inverse relationship which states, okay, there's an inverse relationship between the price of a good and the quantity. Okay, what does that mean? If you as the price of goods rises, becomes very expensive for consumers, and the more the price of the good rises, the less consumers will buy of it. And conversely, as the price falls, okay, consumers buy more. Of course, there's I can hear people thinking, but aren't there other factors as well that are involved in the quantities that people buy? Yes, of course there are, but just a very general and I suppose, as is the way of economics, is we've got to just try and put things into a little bit of a box, a little bit of a so that we can work with it. But just in general, what we're saying over here is that as a general concept, okay, as prices rise, then yes, okay, there's more. The likelihood then is that consumers will buy less of that particular product. Okay, let's have a look over here. Okay. We're going to move through this a little bit. Okay, economists attempt to capture various influences, which we've spoken about a little bit before, which are consumers' incomes, their tastes, their preferences, prices of other goods, substitutes, and complements. Okay, and we try and put all of this together into what we call the demand function. We're going to try and explain demand via these various aspects. So the quantity of demand, and X could be anything, X is just the particular good that we're looking at the moment, is a function of what? P, the price of X. Let's just say, for example, an example that we're going to be using over here, the quantity X is the demand for T in a month. The price of X, how much does T cost per box? I, how much income, okay, the particular household has got. And PY is the price of another good. In other words, is there something that's similar to T or a substitute for T? And of course we look at that because if the price of T rises too much, what would we say? Okay, we're going to go and buy something else then. Okay. Top of page 3, we look over here at the demand function. Let's have an example over here. And just remember, guys, these are not numbers that we've gotten from anywhere specific. It's just an example. So the quantity of demand for X or T is 90. Okay, that's just a coefficient that we put in there, is minus 5.5 times P of X, the price of X, plus 0.3. And again, guys, don't look for these numbers anywhere. They're not specific to, just an example that we put together, minus 2P of Y, any other kind of substitute. Okay, so it's just really we put numbers in to try and make our equation work. And of course, for each and every different type of good, you'll have a different equation. So please don't try and learn these particular numbers off by heart. Okay, what do you notice though? Something that we do notice about this particular equation, okay, that the coefficients for T, the price, remember price is P, is negative. What does that mean? Now, can you see, guys, the inverse relationship between the quantity and the price? In other words, as minus, quantity is a plus. In other words, as the price goes up, as the quantity goes up, plus the price will go, seem to be an inverse relationship then to the price, and so to the other way around. Okay. And consumers' income, okay, we can see over there, it's got a positive relationship to demand. There we go, income, why? Because as income goes up, so probably our demand will go up as well. We're able to buy a little bit more. Okay, everybody see that over there. Okay, we move on over here. Okay, and let's carry on. Okay, let's have a look at our example over here. Let's just say, for example, the price of T, that's P. Okay, and let's just assume that the price of T is $2 a box of T. Okay, income is $50, and the price of not necessarily a substitute to T, but something that would complement that is $20. Okay, everyone comfortable? It's really a case of plug and play over here, guys. Okay, remembering again the 90, and I'm just going to change my color over there for the 90. Okay, is a fixed number. Everyone comfortable with that? The rest of it is plug and play. We know where we get everything from. There's the 5.5, there's the 0.3, and there's the 2. We're just plugging in the actual numbers then that we've got. Let's put some color to that. Okay, and there is the $2 per T. Okay, there is the $50 of income, and there is the $20 for the price of sugar. We plug and play everything. And now remember, what am I trying to work out? Always come back to what you're trying to work out is the quantity D, demand of X. In this particular case, X is the T, and we get to an answer of 54. And again, that'll depend on what you're looking at. In this particular case, it's boxes of tea. So our demand, our QD, the quantity demanded, would be 54 boxes of tea. Keep in mind, of course, guys, remember that what? That P of X, which is a negative, that's the price of tea, would indicate to us what? That as the price of tea rises, consumption would go down, and we know the variable now, don't we? What's our variable? 5.5 boxes. So if you're going to raise then the price of tea, okay, well, you must understand, what are you doing? You're going, as you raise the price, okay, then our consumption is going to go down. Okay, in our example that we've given you here, and guys, remember this is a specific example to the specific case. Okay, there are 3 independent variables in our demand function and 1 dependent variable. If any of the independent variables change, okay, we can see if we can change anything of our 3 over here. What's going to happen? The quantity demanded, QD, is going to change as well. Okay, in our example, let's have a look over here. We made our values 50 and 20. Okay, and yes, you can rewrite the equation as you like. There we go. And keep everything, make your numbers as constant as possible to try and isolate specific what you want to in this example. We can take those. We've got the 90 as well. We can put all of those together, giving me 65 once I multiply them all through. Okay, and then what could we say? We could say the quantity of tea demanded is a function of the price of tea. At this point, $5.50 per box of tea, per household income, okay, 500, and the average tea price then of price of sugar, okay, of $20. Okay, it's important to remember, of course, guys, that income and sugar, they're not ignored, they just added to the constant number there of 90. Okay, so what we do is we're really just putting them all together in a new, what we call a new constant term, so we can look at them as one specific number. Okay, and then just really focus then upon what? Quantity of demand versus the price then of the particular good, to try and isolate it as much as we can. What you can also do, remember, guys, is just the maths behind this particular demand equation. You can solve for the price of X. Okay, how would we do that? I'll just take quantity from being on the left-hand side to going to the right-hand side, and it really just moves it around, doesn't it? So I put price there and quantity over there. What are we doing now? Well, now we're just saying, well, hold on a second. Since I've got price there on its own, gives the price of tea as a function then of what, guys? Quantity of tea consumed per month. Okay, and all I've done over here, and it's got a fancy name, doesn't it? It's called the inverse demand function. Okay, and we can see over here, what do we say? The quantity of tea demanded, in this particular case X, which we said is T, must be less or equal to 65.29, such, of course, then, guys, that the price is not negative, because if it was anything, and we can just run those numbers, it's nice and easy, okay, because if it were anything different to that, and of course, how do we get to that? It's really just these two numbers. Let me highlight them for you. Okay, it's the 11.81, okay, and the 0.181. Remember, guys, if you just put the one over the other, 11.81, okay, which is our constant, over 0.181, I'm going to get to 65.29. Now, if is exactly what we say, if quantity is, it's got to be restricted to less than or equal to, because the minute we get to anything more than 65.29, what's going to do, what will that particular equation do to my price? It will set a negative price, which of course it cannot do. Does that make sense? Okay, so if this particular number, quantity demanded, okay, is more than 65, remember that's a minus, just run the numbers, and I'll just show it to you quickly just to make sure everyone's got clarity over here. Let's just say, for example, in this particular example, I set my quantity to 100. Everyone comfortable with that? Okay, and so I go 100 times 0.181, don't forget that's a minus, okay, and I get to, so let me just do it again, I got 0.181 minus, and I times that by a quantity of 100, I get to this particular part of my equation equaling to minus 18.1. The first part was 11.81. Okay, and what of course does that give me, guys? It gives me a price that's equal to minus 6.2. Now of course I can't have a negative price, no one's giving stuff away for free. Okay, everybody comfortable with that? So just watch for your particular numbers as you run through the equations. The graph of the inverse demand function is called the demand curve. Okay, look at this demand curve, because this is what we're going to be spending quite a bit of time on. Okay, and look over here, there's your 11.81. Okay, that's my constant. Okay, and then over here 65.29 is the quantity. Can you see? Remember what we said, you can't move too much away from the 65.29. Okay, because the minute it goes higher than 65.29, okay, what happens to my price? Okay, that'll knock into a negative, and that obviously can't work. But what do you notice? Look at your demand function. There it is. What do you notice? Change color. As I move my price, okay, down from 11.81 down to 3. Oh, look at that. 2. Okay, can everybody see what's happening over there as we move around on the particular pricing? There is my, what we call my demand curve. Everybody comfortable? Okay. And what does it tell me? Let's just try and get a bit of understanding behind the demand curve. It's the highest quantity willingly purchased at each price, okay, for that particular quantity. Let's have a look over here. The household will be prepared to purchase 54 boxes of tea at a price of $2. Everybody comfortable with that? If you want to now take the price from $2, where we're going to be purchasing, read the graph, $2, where we'll purchase 54 boxes of tea. Now we're going to raise the price. Take the price up to $3. What's going to happen? Okay, now we're only going to purchase 48, and that makes sense, doesn't it? Because the price has gone up. I am prepared to purchase less. Well, I can afford less, perhaps, or whatever it happens to be. Okay. As promised, of course, guys, you're going to have lots of equations over here, lots of graphs. Okay. The slope of the demand curve is measured as the change in price. So there's my slope, there's my demand curve, it's slope, okay, and simply over here, change in price over change in quantity. Okay, if I just say, okay, well, hold on a second, what is my slope over here for this particular demand curve? There's the 1 over minus 5.5. Now, hold on a second, you say to myself, where's the 5.5 come from? Let me just take you back a little bit, just to make sure we've got clarity over here. Okay, and remember what we said here, guys, just clean up a little bit. Okay, there is your 5.5. Everyone comfortable? So when we look at the particular demand, 5.5 is over there. Everybody comfortable with it? Remember what we did in this particular demand function, we moved things around, okay, as we try to isolate specifically just price and quantities. Okay, so there is your slope of the demand curve, again straight from the demand function itself, the quantity demanded function. Okay, let's have a look over here. Okay, in addition to that, not just looking at price, we also want to measure how sensitive the quantity demanded or supplied is to the changes in other variables, not just price. We come to this concept called elasticity of both demand and supply. Beforehand, the equation was a nice linear equation. We love linear equations. It's a nice straight line, easy to work with. And we said over there, the quantity demanded of product X, which we defined as T, was 65 less 5.5 times the price of that. Okay, and then if we had to ask ourselves the question, how sensitive T is demanded to changes in price? Well, that's nice and easy, because what could we do? We could say, well, whenever price changes by a unit, quantity changes by 5.5 units. And of course, we know it's inverse relationships that will change in the opposite direction. If price rises by $1, what would we say? Okay, demand falls by 5.5 boxes, and that's evident then in that relationship 1 to 5.5. Okay, and very simply, what would we say? The coefficient on the price variable is a sensitivity measure, nice and easy. Okay, good. Economists, therefore, sorry, just one stage up. Okay, this particular relationship, difficult to extrapolate that to other units of measure, onto things like grams, euros, things like that. Quantity a little bit easier, but other units of measure not so much. And based on that, the economists want to use a measure not just of that, but of sensitivity that's not dependent on units of measure. And we call this measure, guys, the measure of elasticity. And it's a sensitivity measure. So elasticity is the general measure of sensitivity of just one variable to another. And because it's one over the other, it's just one over the other. It's a ratio, isn't it? Okay, simple as that. It's the change, the percentage change in y over the percentage change in x. Now, of course, we're going to define x and y, but that is any kind of sensitivity measure. It's just one over the other. When one changes by a certain amount, how much does the other change in relation to that? Now, nice and simple, what do we have? Elasticity of demand. Look, and guys, just be a little bit mindful over here not to be overly awed by all the notations, because it's fairly simple. Look at this one. It's the E, the elasticity, D of demand of the price of X. And remember, we defined X in our particular example as T, but X could be anything, couldn't it? Okay. Now, what is the elasticity of this particular? Let's have a look. It's the percentage change in the quantity demanded of product X over the percentage change in price. In other words, as you change P, the bottom, the price, how much does the price change by? 5%. Quantity, how much does that change by? The quantity demanded, 10%, and then you can work out your elasticity. We'll look at an example for that now. Okay, and as I say, guys, I don't want to scare anybody, but as you move down, you see these horrible looking equations. We're not going to focus too much on the detailed equations. We're going to focus on the understanding of them, what they comprise, and how we work with them. Let's have a look. Okay, if the quantity demanded, this example, falls by 8% when the price rises. Just one thing I do want to stress over here again, and we keep stressing, I know, making people a bit crazy, but please always keep noticing in the demand equation the inverse relationship. Quantity falls, prices rise, and of course we know it goes the other way as well. Okay, so simply speaking over here, guys, if the quantity demanded, quantity is always the numerator. Okay, if the quantity demand falls by 8%, and that's just that's the percentage change in quantity demanded falls by 8%, and price, which is my denominator, okay, rises by 8%. The elasticity, remember that's a minus because quantity fell. What is my elasticity of demand? Minus 0.8. Is everybody comfortable with that? Okay, now we play with the equations a little bit, but let's get a bit of an understanding. Okay, we can expand this equation just using the maths, that the percentage change in any variable of x is really the change in x divided by the level of x. Okay, which is just quantity and price over there. Nice and simple. Okay, wow, look at that. That looks fancy, doesn't it? Okay, that was my original elasticity equation, wasn't it? Okay, and now you're just saying, well, it's the percentage change demanded over the quantity and price, change in price over the original price, and there's nothing new over there. That's all things that we've all seen before. Don't be overly impressed. Okay, and now they're just putting them one next to each other. Percentage change in demand over the percentage price, price over x. Simple as well. Okay, but it's just really to rewrite that equation, but nothing more than that. Let's have a look at an example to try and clarify. Remember my initial equation, the quantity demanded of x is 65. That's when I've isolated all of the numbers, minus 5.5 price. Okay. When the relationship is linear, the change in quantity demanded divided by the change in price is what we call the slope coefficient. Okay. In our demand function, we've spoken about that already. Okay, in our example, our elasticity of demand is minus 5.5 times by the ratio of price to quantity. Okay, and let's go and pick ourselves a price to calculate the elasticity coefficient. Let's go back to our original example, okay, of $2. What would we say? Okay, we can now find the quantity associated by the price, that particular price, because we're going to be using $2, and we input that into the demand function. There's my 65 stays the same, my 5.5 stays the same. I'm just going to put something in over there for the price, which we said was $2, 54 boxes of tea per month is my solution. Okay, what does this tell me? Okay, the result of our calculation is only talking, first remember guys, at a specific price, $2. At that price, the elasticity of our market demand is minus 5.5. I'm just plugging this straight into our equation over here, guys, 2 over 54, which is giving me, and where did I get this equation from, guys? Just over the previous page. Remember this equation? Oops, there we go. Nothing too crazy, is it? Okay. And I come out with an elasticity, okay, of minus 0.2, okay. And remember, it's very specific to the data that I'm dealing with. So if I'm talking about specifically a price of $2, in other words, when the price is $2, a 1% rise in price will mean that my quantities, and because it's a minus, isn't it, guys? My elasticity is a minus, means demand will fall by 0.2%. What would you say? Okay. When the price is $2 a box, well, demand's not so sensitive to changes in a 1% rise in price. Okay. Because the price goes up by 1%, okay, quantity doesn't go down by so much, but it goes down by 0.2%. You could probably conclude that demand is inelastic. Everybody comfortable? Okay. And what would we say when the price elasticity has a value less than 1? It's inelastic, generally greater than 1. We would say it's fairly elastic. Okay. When the elasticity coefficient is minus 1, demand is said to be unit elastic or unitary elastic. That's exactly in the middle. Okay. But we know as well, guys, that if we keep on with our law of demand, elasticity of demand will always be negative. Why? Because remember, what do we always say? A rise in price, a rise is positive, is always associated with a fall in quantity, negative, because of the inverse relationship between the two. Okay, but the truth be told, it can be elastic, very sensitive to price changes, or not so sensitive to price changes, then we would call it inelastic. What do we see? The first term in my equation, change in quantity over change in price, is the inverse of the slope of the demand curve, is constant across the entire curve. The second term, price over quantity, okay, will change depending on where we are in the demand curve. Of course it will. What do we know? At very low prices, the price over quantity is small. Demand is inelastic. It doesn't move around that very much. When prices become very high, what do you know about quantity? It's the inverse ratio. Prices become too high, quantity starts to reduce, prices are too high, and P is high. So therefore the ratio then would be high, demand is elastic. So look over here, price. As price is very low to the midpoint over there, which we call unit elasticity, it's the midpoint. Okay, till that particular point, what would we conclude? That low prices, inelastic demand. As we move prices upwards, what do we notice? Okay, elastic demand above the midpoint. Everybody comfortable? And of course, guys, what do we notice as well? Okay, it's a demand curve that is negative. It's linear, yes, but it is negative. It goes down. If it were a positive curve, of course, guys, it would go upwards like that. Okay, let's have a look at some extremes of price elasticity. Okay, we've got two interesting cases, vertical and horizontal curves. Remember, if I just had you guys, and let's just do a quick revision over here, give me the name of this particular demand curve, you would say, yes, it's linear, it's a straight line, but it's negative. Okay, it's a negatively sloped linear demand curve. If it were, I'll just change our color over here, if it did something like that, that would be a positively, okay, sloped, but again, linear demand curve. We've got two special cases, vertical and horizontal. Well, look at that. There is your vertical curve, okay, and there is your horizontal. Okay, of course, there's never going to be a time where a demand curve is perfectly vertical at all different prices. Okay, but we've got certain prices, okay, that over certain of the range of prices, the same quantity would be purchased no matter what. Okay. Okay. So in that, whatever that happens to be in a particular price range, quantity demanded isn't sensitive to price. Let's say I'm working over there. So it doesn't really make much difference if you're charging $5 or a bit lower, $4. Okay. Well, the quantity will be exactly the same. Okay, and that's what we call perfectly inelastic. Okay, we look over here. Okay, and even a minute price increase will reduce demand to zero, but at that particular given price, okay, the consumer would still buy some large amount, unknown amount. Okay. We'd say that the demand curve facing a seller in terms of perfect competition would be perfectly elastic. Everybody comfortable with that? Okay, that talks then about the horizontal. Let me just go back a little bit down there. Okay, over here. And what do we notice about the horizontal curve? That it doesn't make any difference. Well, every little drop of price, my quantities here, look at my price. My price is there. What happens if I move my price a little bit down to there? Okay, my price goes down. Look over here. Okay, and you can start to mess around with that a little bit. Okay, okay, and this is exactly what we're saying over here. Even a minute price increase may well reduce the demand to zero. Okay, so we've got our various quantities. Okay. It's called a horizontal demand, has infinite elasticity, called perfectly elastic. Doesn't matter what you do. Okay, look, there's my quantity over there. Everyone comfortable? Okay, we move down a little bit over here. Predicting demand, is it possible to predict the elasticity of demand? Okay, well, what do we know? That elasticity of demand, let's just do a quick revision. Now, we don't want to get too technical over here, but elasticity of demand is what guys would tell us. Okay, it's more sensitive. Okay, if there's substitutes, very sensitive. In other words, if you've got something else, I don't care. There's two different kinds of tea, so it doesn't make a difference. I'll buy either one. Okay, it occupies a large portion of the total budget. It's optional instead of necessary. If it's optional, and if I've got money, then I want to buy the tea. But if you're going to raise the price too much, then no, I won't drink it at all. So what? No problem. Okay. Have longer adjustment times and other possible determinants. We'll talk about that as we go forward. Let's talk about elasticity and total expenditure. Okay. When demand is elastic, can move around a lot, the price and total expenditure go in opposite directions. Okay, when demand is inelastic, price and expenditure go in the same direction. Okay, and you can easily identify the relationship. Okay, by looking at the linear demand curve. Okay, remember what did we say before when we looked at the linear demand curve? Let me just draw it for you quick over here. Okay, and what did we say? There is your curve. What was in the middle? Really in the middle over there, the midpoint. Okay, so anything above the midpoint, and there was pricing, wasn't there, is elastic. Below the midpoint, demand is inelastic. Okay, we've got a big picture for you over here. There we go, and that's our picture, isn't it? Okay, and here is, let's just say, for example, here is my midpoint. Okay, above the midpoint, there's pricing, there's quantity. Above the midpoint, we'll keep it in yellow. Okay, a fall in the price, okay, will result in, of course, that's the elastic range. Below there's the inelastic range. Okay, let's just first talk about the elastic range. A fall in price, okay, accompanies a rise in expenditure. So as you see what happens over here, a fall in price. Look what's happening over here. Expenditure, oops, that wasn't really well drawn now, was it? Let's just clean that up. So a fall in price will represent a rise then in total expenditure. When I'm now moving into the inelastic range, what happens over here? A fall in price, prices are going down. What do we notice over here? A fall in price will result in a fall in expenditure. Everybody comfortable? Okay, I'm not going to spend too much more time over there. We move over here, income elasticity of demand. So now we're moving to income elasticity. Okay, now what does income elasticity mean? Well, it's elasticity, in other words, how movable it is, but now we're talking about in terms of income. Okay, now I keep everything else constant, but what am I going to change now? We keep pricing constant, we keep everything constant, except now I'm changing my levels of income. Now we can see again, guys, look at the equation. The elasticity of demand, and you see over here, I'm relating now that to the I, to the income. And it's exactly the same thing. Elasticity is a sensitivity measure. So my numerator is how much is the change in quantity demanded of product X over or as a result of what changes? Changes in income. And they're both percentages. That's why it's a nice measure called elasticity. Is everybody comfortable with that? Okay. Let's have a look. Example. If the income elasticity for any certain good, let's call it our T, has got a value of 0.8. What does that mean? That if income rises by 1%, my denominator, the demand at that particular price would rise by 0.8. Everybody comfortable? Okay. And it's a bit of repetition, I'm sorry, but good for revision at least. Own price elasticity is always negative. Income elasticity of demand can be positive, negative, or zero. Let's have a look what that means. If I say to you, we are experiencing positive income elasticity, that means that as income rises, I demand more of that particular goods. And that's generally for normal goods. What about negative income elasticity? In other words, I get more money, but I'm buying less of these goods. Okay, these are typically inferior goods, because what's the person going to say? Well, when I didn't have so much money, I was forced to eat things like rice and potatoes. I don't think that's so bad, by the way. But anyway, okay, it's in the example. And maybe less expensive cuts of meat, okay, which we maybe term as an inferior good. Now that I am earning a lot more, I want to eat much fancier foods, okay? And that's why negative income elasticity, guys say, well, I've got negative income elasticity. First of all, what does that mean? That means that, as a person earns more, they spend less on that particular good. Okay, everyone comfortable with that? We move down to the next concept. Cross price elasticity of demand. Okay, previously we spoke about what? the good's own price elasticity. Okay, but what about cross, another good? Let's say, for example, the price of another good might also have an impact on the demand for tea. What happens if we're talking about another product? Let's say, for example, coffee. Okay, and what we need now to be able to do is to define an elasticity with respect to the price. You can see what have I changed, guys. Look at my equation. Here's my normal equation. My quantity of demand is still percentage changed in quantity demanded of X, T, over what now? Now look what I've changed. Look at my denominator. The percentage change not of the price of X, but the price of Y. What's Y? That's another good. Okay. Everyone comfortable? Okay. The cross price elasticity measures how sensitive the demand for my good X, is to changes when we start to change the prices of product Y, another good. Okay, everyone comfortable? Now, let's just say I've got a pair of goods X and Y. My product is X, the new one is Y. When the price of Y rises, okay, let's say, for example, more of X is demanded because the price of Y just got too much, we would say the cross price elasticity is positive, and they probably substitute, and they're very similar products. Now, if they're very similar products, what would you tell me? That's why, if they're very similar products, if you rise the price of my competitor Y or my competitor product, okay, well, I'll just buy more of X then, because they're the same thing, really, aren't they? They are substitutes for one another. When I've got cross price elasticity being negative, we say those are complements, they work together. Okay, such as gasoline and automobiles. Okay, when prices of automobiles fall, okay, what might you expect? The quantity of autos demanded to rise. Why? Because the price has gone down. Oh, prices have gone down. Fantastic. I can afford to buy a better, bigger car. And then also we'll see a rise in the demand for gasoline, because if I'm buying bigger cars, I'm probably going to be spending more than on that. Okay. We have a look at our example over here. Okay. Cross price elasticity of demand. Using the demand function which we had before, quantity of X, and there was all my numbers over there. Okay, the price of X, income, and the price of Y. Everyone comfortable with that? Let's say, for example, I choose my price of X, okay, to be $2, income $50, and $20 for the price of Y. When I now come and substitute all of that then into my own price, and why do I call it own price elasticity? Because it's for the and always look at your equation to see where you're working, guys. The quantity of X over the price of X, I get minus 0.20. Okay, when I calculate income elasticity, I'm doing quantity of X over changes in income, I get to 0.27. Cross price elasticity, okay, I'm now doing the changes in quantity. The numerator, as you can see, guys, all remains the same. It's the denominator that changes. In the first case, it was price of X. Second case, it's the price of, not the price, the income levels. And the third one is the changes in the price of Y. Everybody comes with that. So we can see that I'm not going to spend too much more time on that, but we've gone through three different types of elasticity. Own price elasticity, in other words, when the price of my own product changes. Okay, then we said, what about income elasticity, when my income changes? And then what about cross price, when the price of a similar product, whatever that product is, in this particular example, product Y, when that changes, what does that then do to my numbers, my elasticity? Okay, and all guys, always watch the sign of elasticity, whether it's positive or negative, because that'll obviously say, well, when one goes up, the other negative goes the other way, positive moves in the same direction. Okay. We now move to talk about earning outcome statement, compare substitution and income effects. First of all, what is substitution? Okay, and we talk about these two impacts that'll impact a consumer, okay, when its price moves around. Okay, as you change the price of a specific item, what does that then do? We look at two specific, okay, things called substitution, as well as what we call the income effect. Okay, by way of example, when the price of something, let's say for example potatoes, falls, okay, it becomes relatively cheap or less costly compared to similar things that a consumer might purchase. So when the price falls, okay, it's cheaper than rice, and what are you going to do? Okay, well, I'll buy more potatoes, less rice, because okay, that's the substitution effect. So okay, well, they're quite similar to me, okay, so if it becomes a bit cheaper, well, I'll buy more of the cheaper one, less of the expensive one. Okay. Consider a consumer spending all of her income on a combination of goods and services. Earns $100 and spends all of that on a combination of goods and services. Okay, and now let's say, well, the price of something she was buying all the time starts to fall. Okay, her money income and the price of the other goods remain unchanged. Okay, we call this the increase in purchasing power or real income. Okay, for most goods and services, consumers buy more of them as their income rises. As you get more income, okay, so when the price of a good, let's say for example potatoes, falls, we buy more potatoes because I've got more income. Okay, although the consumer's money income, in other words the amount of money that they get in, is assumed not to have changed, real income has risen. Why now? Because your actual money that you got, you still had $100. You still earned $100, no change over there. But because the price of something that you normally buy, in our example, potatoes, has fallen, so in fact, you've really got a little bit more real income. Does that make sense? Okay. We can see the interaction then between substitution and income effects. Let's talk about normal goods and inferior goods. Okay, we have spoken about this a little bit already. Okay, if a good is a normal good, okay, a decrease in its price, okay, it's normal, that's what you like, it's what you normally buy. Now you lower those prices, we're going to buy a little bit more of them. Okay, let's talk about normal goods. Okay, clothing. Okay, as people earn a bit more, they may tend to buy more for clothing. The substitution and income effects reinforce one another, okay, and cause our demand curve to be negatively sloped. Guys, just remember again, negatively sloped means that there's an inverse relationship, an opposite relationship between prices of goods and quantity. We now talk about inferior goods, okay, cheaper cuts of meat, generic beverages, okay. And what do we know? As your income rises, people tend to buy less of these particular goods, okay. And inferior doesn't mean anything about the quality, it's just what we talk about the good itself, okay, which would cause people to buy more or less of it depending on their income levels. The substitution effect of a change in the price will always be in the direction of buying more at a lower price or less of it at a higher price. But the income effect of that same price change depends then on what kind of a good is it. Is it a normal good or an inferior good? A normal good, what will happen? The income effect says, okay, will reinforce the substitution effect, okay, and lead to a negatively sloped demand curve. In other words, if it's a normal good, prices fall, well, it's a negative slope, I'm going to now buy more. But an inferior good, okay, what happens with an inferior good? The income effect and the substitution effect work in opposite directions. In other words, the income effect will mitigate the substitution effect. And there's a nice table for you on the bottom over here, just to illustrate those particular points between normal and inferior. Okay, and as you can see, I'll just show you the words. Okay, normal good, substitution, and income, same thing. You buy more and you buy more. For an inferior good, if there's a substitution, you buy more, but income, you buy less. Okay. We talk about over here, top of page 12, describe the phenomenon of diminishing marginal returns. Okay. And we're going to get all of our definitions right before we continue on over here. Okay. We call a specific phenomenon increasing marginal returns. Okay. What does that mean? What's marginal is additional. Marginal product, the productivity of each additional unit of resources increases as additional units of that particular input are employed. Okay. And it's generally a shorter term concept. In other words, the quantity produced by a business that will occur over a short term, okay, that a particular improvement when the amount of variable is added to a fixed input. Okay, so having said all of that, what would we say? A firm can experience increasing returns, okay, from adding labor to the production process. Okay, because and how would that work? How would your returns increase when you add labor? Okay, well, you're going to start to specialize, perhaps things like division of labor. Initially, you had too few workers relative to the work. Okay, and what happens then? All your employees had to multitask, share duties. But now that there's more amount of work, the workers can specialize and do their job more efficiently. Okay. We've got this concept called the law of diminishing marginal returns, that as more and more units of a variable factor production called labor are applied to a fixed amount, things like machinery, eventually output will increase by smaller, diminishing, smaller and smaller amounts. Now, if you want to, once this concept called the law of diminishing returns is actively involved, it's going to need larger amounts of the variable factor, labor, to increase the output by 1 unit. Okay. We talk a little bit about productivity, the relationship between production and costs. The costs of producing anything will depend on the amount of inputs or the factors of production as well as pricing. What are factors of production? Employee hours, machine hours, raw materials, etc. Okay, we're going to focus specifically on labor and capital. There are more as well. Let's say, for example, the labor input is the amount of time the employee puts in. Okay, measured in labor hours per time period. Let's say, for example, per week or per month. Okay, and we can denote labor hours as L. Let's say, for example, the firm is using 2 laborers per week and they work for 40 hours each. L, or my total labor, then will equal to 80 hours per week. Capital, I'm never sure why capital gets a K. Cost of capital as well is gets a K as well. Interesting. If the firm is using 4 machines, okay, and each one is used for 12 hours, okay, my total capital being used is 48 machine hours per week. Okay, input prices then would be the wage rate per hour, and for capital, the rental rate per machine. Okay, and now we can come to the total costs of production. Okay, the total number of hours of labor multiplied. Okay, total cost of production, labor by the rate, and capital by its rate, or the rental rate. Okay, the cost function, okay, C is equal to FQ. Q, what's Q? The flow of output, okay, in units of production per time period, okay, and relates the production cost per time period to the units produced in that exact same time period. Okay, what are the 2 things that could cause the cost of producing any given level of output to fall? The price of the inputs fall, either labor or capital, and the inputs themselves could become more productive. Okay, let's say the laborers can do what they did before in much quicker time, and less of them would be needed. Okay, and the reverse is also true. Okay, productivity is important because cost minimization versus, that's always, either you're going to do one or the other. You're going to minimize your costs, you're going to maximize your profit. They tell us that the firm always wants to maximize productivity. The firm that falls behind in industry productivity, okay, puts itself at what we call a competitive disadvantages and will experience reductions in earnings and shareholder wealth. Okay, let's have a look over here. The benefits of increased productivity are lower business costs, an increase in the market value of equity and shareholders' wealth, and an increase in worker rewards. Now we come up with some more concepts. Okay, total, average, and marginal product of labor. Okay, and when I'm trying to measure the firm's operating efficiency, it's often more practical to use a single resource, okay, factor, okay, and most commonly used is labor for measuring productivity. Okay, but it doesn't have to be. Okay, let's look at some of my definitions. Okay, total, marginal, and average product of labor. Total product, Q, is the total sum of production during whatever time period. We call that Q. We use labor quantity, which is L. Okay, let's have a look at my average product. Look at the words again. Average product, guys. Okay, is measured on the basis of labor input. Average product of labor measures the productivity of an input. Again, we're going to be using labor as our input on average. And look at the calculation. Okay, we get that by dividing the total product by the total units. That will just give me my average. Okay, it's not going to tell me anything about individual workers if they're being efficient or not, because it just gives me a total average. Marginal product is the amount of additional output that results from using one more. Marginal is the additional. If I add in one more unit, okay, of that particular input, okay, assuming my other inputs are fixed and cannot change, what will that then do for my additional unit? Okay, if I add in one more unit of labor, keeping everything else constant, what will that then do for my productivity? Okay, let's have a look over here. We look at a nice example. Okay, total, average, and marginal products of labor. The firm's got 20 acres of land. Look over here. So remember, look at that. That stays the same. I start off with 0 units of labor. If I've got no labor, it doesn't matter, make a difference how much land I've got. I can't produce anything. 1 laborer, I can produce 10. 2 laborers, 22. Now you can see already that there's been an increase. Okay, first of all, let's look at some of the numbers. So I'm producing 22. I've got 2 units of labor. Can everyone see that that's my average, which would just be 22 over 2. What's my marginal? My marginal is my additional. In other words, let's take a look over here. With 1 worker, what did I produce? 10. And I've got now added a second worker. What did I produce? 22. What did he add? What was the marginal? What was the addition? Can everybody see? It was 12. And so you go through your table. Okay. Is everybody comfortable with that? So nothing too crazy. I'm not going to spend too much more time over there. Can everyone just see the various calculations? Again, look, what am I working with? Total, produced, marginal, and average. Average is always just going to be taking the total product divided by the units of labor. There's 7.4. Just something interesting to point out over here. What do you notice? As I move from 9 laborers to 10 laborers, my total, okay, in fact goes from 76 to 74. I'm lowering, so you can see there's a -2. As a result of adding in an additional worker number 10, my total output dropped. What would you say? Well, don't hire the 10th guy. Okay, we'll talk a little bit more about that. Okay. I think probably a good point to take a break in this particular video. We have been going for quite a long time. We will stop over here just for a break in video number 1, and we shall continue onwards then in video number 2. Continue on then with page number 15.